All right, welcome everyone. Thank you for joining Tech Academy's Friday Tech Talks. And today we actually have one of our graduates, Chris Carter, and they're going to talk about basically agile development and enterprise and in an enterprise. So thank you for being here and take it away.
All right. Well, welcome everybody. Uh, the title of this talk is Enterprise Software Development, the Sprint. And the idea is just to go over, what it's like to work in an enterprise environment and how your day and your week is structured. Just a little bit about me. I did graduate from Tech Academy in 2016. Moved right into a contractor position through Vanderhewen at Intel, which was fantastic. After that, through Apex Systems at US Bank. And about halfway through that, I transitioned to being a full-time employee at US Bank. So I got to see both sides. And they're definitely different. There are pluses and minuses to each one. It's really nice to be full-time because it gives you a lot of security. Although as a contractor, it was kind of fun because they usually give you some sort of a project and you just get to go work on that project. And you get to kind of make your own hours and you get to kind of be a lone wolf sometimes. So, both sides have their pluses. And then most recently, since 2021, I've been at Genesis Financial Solutions. And that's been fun because I've got to be a lot more involved in the DevOps, deploying things, managing sprints, managing the code repositories. And that's part of what this talk's all about. It'll dovetail well into David Meyer's talk on DevOps last week. So the target audience I was thinking about was the person here, maybe halfway through boot camp, thinking about either 2 weeks in the future or 2 months in the future when they're going to be hitting that magic Monday, going to get their badge, and then they're going to be in this conference room with a whole bunch of other developers. And what the heck is going to happen in that conference room? So that's what this is all about. So let me start by sort of giving an idea of why we do sprints and why we do Scrum. Initially, historically, we did a traditional software development cycle where the business would develop requirements for the application. They would write documentation. The managers would plan out the work, and then the developers would write the code. And then at the very end, the testers would test it, and it would be deployed. And hopefully you got it all right at that point. But that has been falling out of favor for a number of reasons. First of all, it's pretty common that the requirements aren't fully known at the beginning, and you can't just write out the plan. People may think that the requirements are fully known, but once you start going and asking questions, or once people start to see the product as it evolves, the requirements do change. They change over time and as people see the product. Also, it's nice to do development in little bits instead of all in one big chunk, because if you notice a mistake early in the development, it's a lot easier to fix it than if you notice it at the very end when you're testing this thing that you've been working on for 18 months. So to that end, a group met in 2001 in Snowbird, Utah, and published this manifesto for Agile software development. And they had a number of points, but the important ones I picked out here. They said you should develop and deliver working software frequently. They said from 2 weeks to 2 months with a preference to the shorter time scale. And I'll tell you that I've never actually heard of anybody doing Agile sprints that are longer than 2 weeks. They always seem to be 2 weeks, but there's some frequent delivery of working software. And they thought it was important that the business people and the developers work together, even with face-to-face time throughout the project. And then at regular intervals, not only do you deploy the software, but you reflect on how the team is working so you can develop more effective working styles and rules. There's another thing that was very important. Welcome changing requirements even late in development. That is actually less common. So a lot of places will say that they are agile, and they do this agile time frame but they may not be truly agile because uh, it's still very tricky to change the requirements halfway through. So this one is less common, but these first three are common elements that you'll see on agile teams, at least in my experience. And when we talk about agile, for the most part, we're talking about Scrum. There are different flavors of agile, but 80% of shops say that they use agile at least in part, and of those, 87% are using Scrum. So that's why we're talking about Scrum sprints. So in Scrum, typically you're going to be divided into 2-week sprints and deploy code at the end of each sprint. Each sprint has certain rituals. I'm used to having 5 rituals. The grooming or refinement of stories, the planning of the sprint at the beginning, the daily stand-up pretty much every day, the review and the demo at the end of the sprint where you can show off what you've done, and finally the retrospective where you reflect on what you've done and how you can improve your working style. Scrum team can vary in its makeup, but this is sort of a typical Scrum team. There's a Scrum Master, and the Scrum Master moderates all the meetings. They can help you get rid of blockers. For example, if you need input from some other team in the company to do your work, they can reach out and try to poke them and get them to respond. If you need some uh, um, some access permission, they might be able to help you with that. So they get rid of blockers for you so that you can do your work. And often you'll find Scrum Masters have a certification to do that. So they have some sort of specific training. There's one product owner or PO, and they are the liaison to the business. So if business has a requirement that they need implemented, the product owner is able to translate that into a development requirement. And then there are typically, say, 3 to 5 developers per team called engineers or devs, and 1 or 2 testers, QA for quality assurance, or SDET, software development engineer in test. So that's a typical Scrum team. That's what my team looks like right now. So let's see what it looks like. Here we are at our first sprint. It is Monday. You went and got your badge, and now you're sitting in this conference room. Up top, we've got the timeline. So first week in light gray, second week in dark gray, so you can follow along. So before you got here on Monday, your Scrum team will have kind of set the stage for this sprint that you're joining on Monday. Stories will have been submitted to the team, usually from business, obviously, but sometimes developers will notice something that needs fixing and they will submit something to the team, or the manager may want to implement something as well. But a story goes something like, as a risk manager, I would like applicants' risk scores updated when they're approved. An estimated, and then it goes into a little bit more detail. An estimated risk score is stored in the accounts table at the time of application and should be replaced with a true risk score from the underwriter at the time of adjudication. But if the underwriter's score comes back null, just go ahead and keep the estimate. These stories will have been groomed. Remember, that's one of the sprint rituals. So everyone gets together, they listen to the story, they make sure that the requirements and the acceptance criteria make sense. They make sure that the story is actually ready to be worked. For example, if you are making some changes for a new customer, you need to make sure that that customer has already been added to the database and onboarded to the company, or you won't be able to get the all of the ID numbers and data for that customer that you need. So make sure the story is actually ready to go, and then you assign points to the story, called pointing or point poker. A lot of times the points will go as a Fibonacci sequence. This is typical: 1, 2, 3, 5, 8, and 13. 5, most places I've been, is sort of a full sprint. 3 is full sprint, but you can kind of divide your attention to something else. 1 is just a change in text somewhere, something real simple. 8s and 13s will typically go over into 2 sprints, or they will definitely take up all your time for a whole sprint. And these reflect, they're supposed to reflect more the complexity and the risk of the story as opposed to just the workload. So you may have a story that requires a lot of changes, and it's going to take a lot of time to do, but there's no real complexity to the changes. You're just cutting and pasting something in a number of places. That would typically be assigned a smaller number of points because it's not complex. There's not much risk that it's going to go over. But that'll vary according to where you work, how the points are assigned. And then finally, those stories will be put in the backlog once they've been approved. And so the backlog is basically just a list of work items that can be taken in order into the sprint for people to work on. So let's get back to your first Monday. The first thing that's going to happen on Monday is the next ritual, which is sprint planning. So you take the stories from the backlog, you assign them to a developer and a tester. And if you can work with testers early on in the process, it's a lot easier because they can help to get test cases ready for you so that once you finish with your code, you can go ahead and just plug in these test cases and see if your code's working. So we at Genesis have really tried to get developers and testers working together from day one on a story, and that's really been very helpful. And you keep doing this until the workload is balanced with the team capacity. So the team capacity is, how many points they can do in a sprint. And that's determined from a known historical velocity, the sprints completed, the points completed per sprint for that team, plus the time that's off for each of the team members. So, you may not be at full capacity for the sprint. So you assign everybody their story, and then later on in the day, the developers prepare their work. The first thing you want to do when you get your story is make sure that you understand the requirements, make sure the requirements really do make sense, clarify them with the product owner if you need to. Add tasks to your story. Most of the teams will have some sort of a board, and I can show you the board that I prepared. And so by adding the tasks, the lead developer and the manager can see where that story is and if there's a problem. Typical tasks that we have in our stories are first analyze the problem, then code it, and then test it. You also may add tags to the story, and this has been really helpful for us too. We tag it with the applications that are affected. So if I have a story that affects the customer service and the user interface applications, I put those tags on, and when we go to deploy code at the end of the sprint, we know that for that story, we need to be deploying those 2 applications to the production servers. And then finally, you'll update your story status. It was marked as approved in grooming, and you're going to go ahead and change it to in progress. So you're going to begin your work. You're going to clone the code from version control. So common version control systems are either GitHub or Azure DevOps, called ADO. And these basically are places where the code is kept in a centralized location. So anybody who needs to work with it can download a copy onto their own computer and work on it. And it's not just a single copy. You can have multiple versions of each copy, of each code repository. You have different branches, and each one of those branches will have saved time points along the way. So you can be working on a branch, another person can be working on a different branch, and you don't conflict until you have to merge those branches together for deployment. And also, if you make a change that you decide you don't want, you can go back to an earlier version of your branch. So you've cloned. If you don't already have the particular application on your local workstation, you'll go ahead and clone that code down from the version control system so you have it, and you'll create a feature branch. Typically, you'll take the development branch and you'll make your own feature branch to work in for a while. At Genesis, we have a particular naming convention, which is really helpful for our branches. S stands for story as opposed to a bug or a hot fix. Each sprint is numbered. So this would be a story from sprint 201. And the story number, which is assigned by Azure DevOps, is 75161. And then finally, I'm the developer. And that way, anybody who's looking through the history of the code can see, whose story this is, what story number it is, and where it falls in the sprint numbering. So let's talk a little bit more about branching. So a code repository, say customer service, will have different branches. The master code is the code that's currently in the production server. The release is the code that's about to be pushed into production, and it's basically just being assembled and tested for the final time before it's pushed. Development is where all the testing happens. So after developers finish their code and they merge back into development, the testers can have at it there. And that's where you will pull your new features from. And then the feature branches are basically sandbox workspaces for each developer. The way that version control branching is done in the enterprise environment, most commonly anyway, is called Git flow, and it was developed by Vincent Dreisen. And this is his diagram. It's kind of complicated. So I made my own simpler version. So here you've got your master in red at the right-hand side. That branch obviously always exists, always reflects what's in production. If there's an error in production and you need to make a very quick change, you can make a new hotfix branch, do your work in that, and then merge it back directly to master. If you do that, you'll have to take that and also merge it to development so that development also reflects the latest status. In green, you'll see a developer will make a new feature branch off of the development. They'll work on it. It gets merged back to development. It gets tested there. If external users like retail partners or another division within the company, marketing, needs to test the code to see if it meets their requirements, it may be moved over to a user acceptance testing branch where they can do their own work without interfering with anybody else. So that sometimes happens, sometimes doesn't. You can see then a second developer will make a second feature branch and then return it to the development, merge it back into development when they're done. It gets tested. You can see a green arrow that suggests that maybe some feature was not ready for release, and so it was removed from the development branch. The developer still has it on their local machine as a feature branch, and so they can go ahead and merge it back to development later on. But it was pulled out of development to prepare for the release. So we finally decide that everything is tested and ready to go. We're ready to begin a release. We create a new release branch off of development. We test that. Any hot fixes that need to be done are done, tested some more. And then finally that release is merged into master as it's deployed to production. So it's complicated, but that's a real quick overview of what we mean by branching and why you make new branches to work in. All right, and then that brings us to days 2 and 3, where you're actually coding. Each day from here on out will begin with a daily stand-up. This is probably the most ubiquitous ritual in Scrum. And basically every developer, and often the testers as well, in fact, usually the testers, will answer 3 questions. What did I do yesterday? What will I be working on today? And do I have any blockers? Which is to say, do I need help from the Scrum Master to move forward? And this is very familiar from my previous career in medicine, because every day the medical team gets together and they have daily rounds. And the resident working with this patient will say, this is what happened to the patient yesterday. This is the plan. We're going to get an x-ray and do these labs. And are there any problems that I need the attending's help with? So, very, very much the same process, actually. So everyone does their presentation in the daily stand-up, so everyone knows where the team is. And then you get going on coding. You analyze the problem that you've been given in your story, and you write the code. And it's lovely. This is what you always envisioned that being a software developer was like, just being faced with challenges and writing code. As you will learn at Tech Academy, most of your time as a software developer is actually not spent doing this, but it's the really fun part. So these are the fun days right here. Now on day 4 and 5, hopefully you've finished all your coding. You're still going to do your daily stand-ups, and you're going to move on to testing the code that you wrote on your own local machine against the development environment. The development environment is basically someplace where you can make changes and it's not going to bother anybody. If you mess something up, it doesn't really have too many consequences. And this is called dev test or developer testing. And you'll obviously be revising your code as needed during these 2 days. A little bit about environments. We have these environments, like I say, so that you can do certain things without interfering with other people doing other things. Particularly, you do not want to be interfering with production. You do not want to be testing your new code, making changes in the production database. So what you do is you start in the development environment that has its own server, has its own database, other applications that your application might have to interact with. They're all in one development environment. And this is basically owned by the developers. They can mess it up. It's not a problem. Once they do their work, then the code gets deployed to a test or a QA environment where the quality assurance engineers can do their testing without interference from development and without jeopardizing the production data. It may or may not go through a user acceptance testing environment if there are external groups that need to approve the code first. But eventually it gets into an environment that's variously called staging or product in test. And this is supposed to be a production-like environment. So if your production environment has multiple servers, your staging environment should have multiple servers, because sometimes code acts differently when it has to be run on multiple servers at once. And final testing occurs here just to make sure that nothing bad is going to happen when you deploy to production. And then finally, you'll deploy to the production environment. So now we're in the development environment where you've been doing your testing. And look at that. We've come to the end of the first week. It's the weekend. So have some fun. Don't forget to keep learning, though. It's easy to get your first job and just say, I'm here. I can go hiking all weekend. But it really is a profession, and it's really important to keep pace of new developments in IT, because software engineering is an exciting, fast-paced world. And a lot of the things that I learned, a few years back are already changing. So always keep learning, keep working on your own personal projects, reading blogs, that sort of thing. All right, week 2. How are we doing? Oh, pretty good. We're halfway through the hour, and we're just starting week 2. All right, days 6 through 8. This is the longest batch of time in the sprint. Review and testing. So again, you'll be doing daily stand-ups. And the developers, once they're satisfied that their code is good and it seems to test out well on their local machine, will go ahead and submit a pull request or a PR that merges their feature branch back into the development branch so that the testers can have at it. Now, typically a PR is going to trigger a code review, because before you start merging code into the code base, you want to make sure that it's good code. So you'll put your PR in, and your story status gets changed to code review. And let me see if I can show you what that looks like. Actually, let me go through code review a little bit more, and then we'll take it all as one big batch. So code review, like I say, this is basically where everything gets inspected. We don't want to let anything bad into the code base, so we're going to take our time doing this. We put in the pull request. The code review then validates the code before it gets merged into the next branch. It's an opportunity to share suggestions with your local, with your fellow developers too. So, this is also how we grow professionally. Is we talk about, hey, I would do this differently, or have you thought about this? It may not be a mistake, but you can still find better ways to do things. And it's also an opportunity to develop some common conventions. And this is what's been happening in our team just recently. Is we say, well, I would have named this variable differently because I think it's clearer what it does if you do that. Or you named this private variable with an uppercase name, and that made me think that it was a public property, and that confused me for a few seconds. So you should make sure to keep your local variables lowercase so we know what they are immediately. So these are kind of the three main purposes of a code review. And I wanted to spend some time on code review because David did such a great job with everything else last week. I thought I would just add to it here. So I just expanding on what you should be doing when you're called on to do your first code review. You want to be looking to see, first of all, is the logic correct? This is kind of the obvious thing when you're reviewing code is this code correct? And, I'm first of all looking to make sure that I'm catching any errors in the code. This is the code that I chose, the bad code, and I'm going to make 7 comments about it. See if you can spot them. So the first one has to do with correct logic. This code is incorrect. Why is it incorrect? Because I've added this item list, or this item, to the database. But after I do that add, I need to call database save changes. So this person has forgotten to save the changes, and so it's not going to do what they think that it should do. So that's one comment that I would make. The next thing I'm looking for is it good design? Maybe correct, but maybe it's not designed very well. Does it adhere to the solid principles? And for the solid principles, I will direct you to the Code Academy. We'll teach you, the Tech Academy, that'll teach you all about the solid principles. Is it dry? Are you repeating yourself? Dry stands for do not repeat yourself. Is it going to be code that's extensible and maintainable over time? So here's an example of bad design. So here we have this bad code that calls the database context directly. So it's going to just open up that database and save to it. The problem is that it's then linked to this database context directly. If you wanted to test this code without writing to a database, you couldn't do it. So ordinarily, you would have an abstraction layer and not call this database context directly. It's a little bit technical, but that's an example of a design problem here in this code. It's a lot easier to see readability problems in this code. One of them I talked about earlier. Here's a private string, but it's in an uppercase. And typically in C# and in Java, we will make these private variables lowercase. And that way we know immediately what kind of variable they are. There's a second problem with this, and that is that this variable, while it may have been used in the past, uh, is no longer actually used in the code, which is why it's in this gray color and not white. So this whole line should just be removed. The next line is actually correct, but again, this variable is no longer used in the code, so it should be removed. The third line is misspelled. And misspelling, although it seems like it's a really nitpicky thing, can make a big difference, because every time you see it, your brain has to stop and think about it, and it distracts you. Also, if you're trying to search for database in the code to see every place where database occurs, if you're trying to make a change to the context, it's going to miss this, and you're not going to change this the way you think you should. So misspellings are actually pretty important. And naming conventions. Your group may or may not have naming conventions. And here's where you would make sure that the code follows those naming conventions. Another readability issue down here. So you're saying if this thing is not null, then go ahead and execute what's inside. And what's inside is, if this thing is not null, then go ahead and execute what's inside there. Well, you could just combine these two. You could just say, if item description is not null and item priority is not null, and then you wouldn't have these two layers of nesting. You'd have fewer curly brackets, and it would be easier to read. So there's some examples of readability. And finally, you want to take a look at the performance of the code. Now, typically, performance is not important. If you work for Google, it is, because you've got millions of hits a second, and CPU cycles count. Typically in enterprise development, though, what really counts is how long it takes for the developer to be able to read, understand, and change the code, not how long it takes for the server to actually execute it. So typically, readability is more important than processor performance. But it varies. And if there's something obvious, you should address it. The biggest problem is if you're making multiple remote calls. If you're trying to assemble a collection of information and you go to the database, which may be in New York, and you get one piece of information, and then you go to the database and you get another piece of information. All these electrons have had to travel all the way across the country multiple times. It's several orders of magnitude slower than what's going on locally to the server. So you want to make sure that you don't have multiple remote calls if you can at all avoid it. The final comment I would make here is there's another thing that's missing, and that is that you have opened up this database context, but you haven't closed and disposed of it. And so it's taking up memory space until the next garbage collection cycle comes and says, oh, we're not using this anymore, I guess we can get rid of it. But a good performant code would take an object like this and would close it and dispose of it when you're done with it. So again, the performance issues and the design issues are a little technical to understand. But just in general, these are the four things that I'm looking for in a code review. Correct logic, obviously, good design, readability, and good performance. The biggest question really is, how picky should I be? You don't want to be just bombarding people with these tiny, unimportant details. And this is where you'll just have to get a sense of how your team approaches these issues. A lot of teams will, in their comments, put NP, which means nitpick, which means I know this is a little thing, take it or leave it. It's not important, but I just noticed something. You can comment and still approve the code. We do this a lot. I'm going to approve your pull request, but I will leave a comment just to leave you with a thought. But I'm not going to hang. I'm not going to hang you up for a whole extra day while you address this, and I reapprove it. So that helps the flow of the team keep going, even if you want to share something. And you can make suggestions. How open people are to suggestions is going to be a part of the local culture that you just have to kind of figure out over time. And let me kind of show you, hopefully, in real life, what this looks like. So let me open up something else. All right. And predictably, time is getting short, so I'll try and be quick here. But can you see my Visual Studio here?
Yes. I'm curious to see how big the text is once you do start typing.
What's that?
So maybe I'm curious to see how big it is if you are going to
Oh,
show some code.
okay. I'll try and make it a little bigger. No, I'm actually not going to really show code.
Okay, got it.
But here I have this to-do list that I've kind of prepared. And this is actually where that bad code came from. I made some better code based on that. This is another thing. When you're doing code reviews, a lot of times it is useful to review the code in Visual Studio and not just in GitHub or ADO, because you can see some things in Visual Studio that you wouldn't otherwise see. For example, here you can see that I'm calling Entity Framework Core, but apparently I haven't brought that library into my solution. And so it's underlined in red saying this is an error. So it does help to do your code reviews in Visual Studio. But I made a number of changes, and those will show up in the Git Changes
Also, if
tab
you could
here.
make it just a little bit bigger, that'd be great.
Let me see if I don't think I can. But I'm not going to do very much more here. I've committed these changes onto my local machine, but I want to push them to the remote machine so that my fellow developers can review them. And I hope this works. So I'm going to push them. Initiating push. Do I have permissions? I do. Awesome. Oh, no, I don't. I'm not authorized. I was afraid of that. Let me go ahead and just show you what things might look like on the other end, though. A window, and there we are. All right. So this right here, I can make bigger because it's in a browser. All right. So this is Azure DevOps. So this is one of the version control systems I was talking about. This is where you would, at the beginning of the sprint, take an item from the
Not sure
backlog
if
in the
you've
new.
shared it or not yet, but we
Oh,
can't see it
I
on.
not? Oh, sorry.
No,
Sorry.
okay.
Oh, I think I need to make this move tab to a new window. There we go. And let me get back to my other window. Technology, it's so hard. Okay. All right,
Google
can you see
definitely
my
forgave
ADO
you.
now?
Looks great.
Okay, great. Excuse me. All right, so at the beginning, I talked about how you would take an item from the backlog in the new status and move it to the current sprint. You can see here I actually have an item for this to-do list that I've already completed and closed. And to move this to the current sprint, it's just that easy. Boom. Oh. And then I might need to save this before I move on. Let me just leave it without saving. Actually sprints. Very slow. All right. Items overview, repos. There we are. So this is my to-do list repository. You can see that it has the master branch in production It has the development branch, and from the development branch, I made this other branch, which is Sprint 1, Story 1, and my name. So now that I've pushed some code here, I'm going to make a pull request from my feature branch into the development branch. And it takes my last commit into my feature branch, which was additional classes, both good and bad. I can add reviewers. I can link work items if I want. I'm just gonna create it. And so here is what a pull request looks like. It'll show the reviewers that are required to approve it. They would approve it by clicking this. It shows the commits that have been made. Only one commit has been changed. And that commit actually did include a lot of files. And so you can see, did I change? Yep, here's bad code right here. So here's that code that I was talking about. And I'll add a comment right here that says this variable is no longer used. All right. And so the person who is submitting this PR will see my comment right here. This variable is no longer used. And they'll see this one. Neither is this. And that's how you would actually perform a code review and implement some of the things that we talked about earlier. Once the person has gotten their approvals and fixed everything that needs fixing, they can go ahead and complete it, which means that it's going to get merged into the development branch. So that's how that really looks like in real life. Now let me get back to presentation. Let's try this again. All right. Where were we? Okay. So we're still in days 6 to 8. We've done our PR. The code review is complete. Now the feature branch will merge into the development branch, and the development branch has been deployed into that QA environment. So this code has been deployed onto the servers in the QA environment, and it's been pointed to the database in the QA environment so that the testers can work with it in isolation from either production or the developers. And the story status then goes to testing. And let me see. It's not very helpful. There we are. All right. We're almost done. Day 9. Again, daily stand-up. We're about to get ready to release this. The sprint is almost done. So the release manager will create a release branch. The developers will raise a PR to merge the feature branch into the release branch once the testers have approved it. And the story status gets moved into ready for staging. The release branch is deployed to staging, and the QAs again test all of the code that's been prepared for this release in the staging environment. And if there are end users that need to test it, external users, they'll be testing it in the UAT environment. And on day 10, we finish up that process, continued testing and staging in UAT. But we also have our final ritual, which is the retrospective. Everyone gets together, they celebrate the end of the sprint, they talk about what went well, what went poorly. Today was the day that we finished our sprint, so we just had our retrospective a couple hours ago. And you may develop action items for future sprints. And you may say that, here we are, it's the end of the sprint. This is when we would deploy the code, right? It's Friday. But typically you don't deploy your code to production on Friday at the end of the sprint. And why is that? Because sometimes code doesn't work out well in production. We just had a story that tested out great in development, tested out great in staging, and then for some reason, it just didn't work well with production. And in my experience, that's usually because there's some bit of data in the production database that's just different than what you have in your lower environments, and your code does not work well with it. But you do not want to deploy to production on Friday at 5 o'clock, and then at 2 in the morning on Saturday, get a call and say, hey, our system's down. So typically, the deployments will be done at some point after the sprint. So sometime after the sprint, the release branch is deployed to production. There's usually a release manager that does that, and there may be a whole DevOps team that does that. Testers will do some quick tests in production to make sure it is working, and that's called smoke testing. And the storage status gets changed to done. And I will just leave you with one of the joys of working remotely. I have different teammates. This is one of my remote teammates that we rescued from just outside the office doing a deployment. So there's the code right there. And there's the deployment. Cover it up. Yep, there you are. So I do enjoy working remotely. It's a lot of fun. I get to play with my squirrel when she comes into the office a few times a day. So that is what all these people are doing all day.
Oh, that was very informative, very detailed as always. So thank you. We do have a lot of questions in the chat. I have one too. So when you first started sprints, what was the most challenging part about it, and how did you overcome that?
Everything was challenging. Understanding the branching strategy was challenging, and I think that for teams, the branching strategy is challenging. But just understanding where the branches are coming from, where they're going to, if they get reset, if you're trying to merge your feature branch back to development, but somebody else has been working on the same code in their story, and now there's a merge conflict. And now you have to figure out, okay, how do I resolve this merge conflict so that both of our changes will cohabit the same code? That's actually probably the number one challenging thing. And it continues to challenge our team and other teams from time to time. And there are definitely treaties written on how to do this, and there may be local techniques for doing it. What we do is we bring it back into Visual Studio and we do a manual merge where it'll show you, hey, these two lines are different in each version. Which one do you want? Or if you want both, pick both. Or if you want to write your own blend of them, you can do that. So branching strategies and merge conflicts are really challenging. And then code reviews, probably not as challenging as merge conflicts, but that's why I wanted to spend some time on code reviews. It's not really clear when you're starting out what's expected of me. Like, okay, here's some code, review it. So what should I be looking for? What sort of things should I be calling out? What sort of things are not important? Um, and that is, hopefully I've given some sense of sort of what to do there. But there's also a lot of local culture that will determine what happens in a code review. So you kind of just have to watch what other folks are doing. It's not uncommon to, especially at first, to do a team code review. So you might want to get together with a senior and just review some code with them your first sprint and see what kind of things they pick up on and comment on. So those two things I think are the big ones.
Thank you. All right, next question. How often do you see stories with a point value of 5 or higher being assigned compared to like a lower point stories?
It varies over time. At Genesis, it used to be that most of our stories that were expected to take a whole sprint were fives. And if it were pretty easy, it would be a 3. And if it were trivial, it would be a 1. And over time, we are kind of evolving to a normal story is a 3. But if it's really complicated and there are a lot of unknowns, then it's a 5. And we've kind of taken the approach that if it's more than 5, we want to try to break it up into multiple stories so that each developer is only taking 5 points per sprint. So we actually don't, in theory, have anything that's above a 5 at all. So again, how story points are assigned and the scaling of story points varies tremendously from team to team and even over time for a team. So that one is where you kind of have to just kind of kick back and see how other people are pointing stories. Good question.
Got it. Next questions. Let's see. Do stories usually get assigned to software developers, or can you choose which stories you take upon?
It depends on the manager. Sometimes you'll just go ahead and say, hey, I want to take this. Or sometimes it'll be very automatic that we're just going to go down in alphabetical order and you take the next story from the top of the backlog. Or the manager may say, this person really knows this domain, and so they should take this story because they've already been working on something similar, last sprint. Or this one is has got a lot of front end, and this developer is really good on the front end, and so they may be tailored a little bit to the developer, and maybe a combination of all those things.
Got it. All right. And these are some of the questions are from the beginning of the talk, so you might have kind of covered them, but I'll mention it still. So next question, can you explain the difference between user stories, blockage, and feature specifications / requirements?
Yeah. So a story is typically just a story. Hey, I have this role and this is what I need to do. And then below that, typically you'll have a description that's a little bit more technical. It says, this information is typically like the one I had, the second paragraph, typically placed in this table. And when we undergo this step in the business process, it needs to be updated in this table. And then finally, you'll have your acceptance criteria, which are the next level of specificity. When I was at US Bank, we would write scripts that converted one input into another input. The acceptance criteria there were very specific. They said, look, this is an example file, and I need your code to convert it to this example file. And you could actually see, okay, this character gets converted to this character. Very specific. Other times, they're not quite that specific, but they're more specific than the story. Where in my story that I had, it said if the value comes back null from underwriting, you should just leave the estimated value in the table. And that's something that might actually be an acceptance criterion because it's kind of a specific little detail. Updates this value. If null does not update this value, updates it for this workflow, but not this workflow. um, and gives this error message if it fails. So you've got the story, you got the description, and then you got the acceptance criteria that each get a little bit more detailed and specific.
Got it. Thank you. Next question. How do you usually go about testing code on your local machine during a DevOps test process?
Good question. Um, so in C Sharp, in a .NET application, there's something called app settings or web config that will basically tell the application where to go look for either other applications it's working with or the database. And usually that's going to be set to the development database in that file. It gets changed as it gets deployed to other environments to point other places. But the code that you pull down will typically already be pointed to the development dependencies in the development database. And so what you do is you just hit debug on your Visual Studio. It'll run the code. And if everything's going well, it's talking to that development database. You can set some breakpoints in the code so that you can stop the execution and inspect what's going on with each of the variables at that point, or to see which breakpoint gets hit to see where it's going. And then depending on what kind of code you're working on, you will call that. I think the most common approach that we have now is that a lot of the code that we write is an API. And so you call that with a tool like Postman, and the Postman has a payload. So you may call an endpoint that says get account, and it'll have a slash and the account number. So you open up your testing tool like Postman. We use Ready API for other kinds of endpoints. And then you'll go ahead and hit run. It'll send the request over HTTP to your Visual Studio, and Visual Studio will run that code. And then you can watch how the breakpoints work. Some code that we run is timed. So I remember I recently ran a job that ran every 5 minutes. And so basically I would start Visual Studio and I would just watch the database every 5 minutes to see, if the data got updated as it was supposed to the next time it ran. But most commonly, you have a tool where you're actually able to call the code and then watch it run locally in your Visual Studio.
Got it. And then next question is from Martin. So he's developing a side project app and trying to practice sprints without the, usual rituals of involving other people. That's been helping him out, pace his workload. What would your thoughts be on practicing Scrum for an indie project in order to stand out as a candidate for a software engineering role?
Yeah, that's not a bad idea. It's really hard to practice it by yourself, but I think that a lot of places will say, do you have experience in Agile? Do you have experience with our Agile tools? And if you can go ahead and set up say an Azure DevOps or a GitHub account, just like the one I showed you. I just set that up last week and just played around with it. Get an idea of how the workflows go. How do you move something from a backlog into a sprint? How do you trigger a pull review or pull request? Do a code review on it, and then complete the merge. How do you generate a new branch from another branch? I think those are all really good ideas. So I would say get either an Azure DevOps if you're committed to Microsoft Stack, or GitHub if you want to be a little bit more generic account, and and just practice making cloning it down, making new branches, merging. The one advantage to Azure DevOps is it combines a whole lot of tools in one. So it has all the team management tools like backlogs and sprints, as well as the code tools like pull requests and branches. But yeah, go ahead and do that. Play with it, and then you can say, yeah, I've totally experienced in that.
Got it. Thank you. There are a few other questions. I know we're kind of past the time. I just want to make sure we
I'm
still have
fine.
the time to get
I'm
over it.
fine.
Okay, got it. Let's see. So this is more on backlog. We kind of went over this, but just a little bit more detailed. So can you discuss product backlog, sprint backlog, or any type of backlog in general?
Yeah. So basically, you've got different groups, primarily business, but also other developers that are submitting requests to your team. Obviously, you're not going to, or at least usually, you're not going to be able to address each of these instantly. So you have to go ahead and put them into a queue. And you also have to be able to reprioritize them. It's not always first come, first serve. There may be, situation where, uh, and most of my experience has been in the financial industry, as it turns out. Not on purpose, just worked out that way. But we're highly regulated, and you may be violating some sort of regulation. And so that would be, top priority, and that would be put at the top of the backlog as the next one to take on that basis. So the backlog is just a collection of stories that have been submitted. It's and they're typically in the new status is when they're submitted. When you groom them, then they move to the approved status, and they can get reprioritized and moved up and down the backlog. But it's basically just a queue where you're going to take your next story from. And hopefully it's a prioritized queue. And that gets put into the sprint. So you're actually working on stuff in the sprint, but you'll be pulling new stuff in for the next sprint, or if you finish early, from the backlog.
Got it. Thank you. And the next question is from Layla. I understand that Agile involves breaking up of project tasks and to fit into sprints, but do you suggest a better way of defining Agile in an interview?
An interview question. Uh, I think that the essence of Agile really is that requirements change. I mean, there's no real reason to split up a project. And in fact, there's still cases where if you know exactly how this is going to go, if you've done this before and you're just developing one more version of it, you may be able to map it all out and do traditional, what we call waterfall development, where everything is all planned out and documented beforehand, and you just do it. And they say, come back in 4 months with the product. Um, but I think the essence of Agile is that you are taking it in little bits because the requirements are going to change. And so you want to be able to have a stopping point where you can go ahead and change the requirements and redo it. You also want to be able to break it up because you want to show your stakeholders each little bit as you develop it. Because you don't want to be in a situation where you've been working for 2 months and they're like, no, that's not what we wanted at all. So um, you're not really breaking it up just for the sake of breaking it up, although it makes it easy to do your work. You're breaking it up so that you have breakpoints to change the requirements if they change in the middle of the process, and that you are continuously showing your stakeholders what you got and getting some feedback from them. And I guess the third thing is you're also testing frequently then too. You're making sure that every 2 weeks you've got code that that works. It may not do everything, but it does the little bit that you developed in those 2 weeks. And so if something is not working and you find out that you need to totally do it in a different way, you're not 2 months down the road. You're only 2 weeks down the road. So I would define Agile that way, is essentially a way to take the work in little bits so that you can respond to and maybe even elicit changing requirements.
Got it. Thank you. Next question. For acceptance criteria that was mentioned in one of the slides that we went over, can you please take any small example and list a few acceptance criteria for it?
Yeah. So I did that a little bit earlier. Like I say, the simplest one was what we had when we were doing the scripting stories at US Bank, where they give you a sample input file and they say this is the output file that should be produced. And that was so nice because it was so easy to test. It either matched it character for character or it didn't. Um, you don't usually have that nice an acceptance criteria, but um, let me think of a good example. Um, so something that's kind of similar to what I've been working on recently. So in the credit card industry, there is regulation around military service members called the MLA, Military. I forget what the L stands for. Act anyway. And there are certain restrictions on what you can do to a credit account when somebody is actively deployed, for example. And so you may have an acceptance criterion that says that you are going to take the MLA flag that's returned from the underwriter, and you're going to add it to a certain table, and you're going to also, and so that's one very specific thing, is it either shows up in the table or it doesn't. And you also may have another acceptance criterion that says that if you add a delinquency to that account and the MLA flag is set, that the account is not inactivated. So that would be another, very specific, very testable point. So the idea is that unlike a general gestalt of what you want in the story, acceptance criteria are very testable points.
Got it. Thank you. And then this is for naming conventions. So did you have a hard time following naming conventions on your code when you first started in this field?
No, I love conventions. I'm actually usually the one that's poking people about conventions. Um, no, I found it to be pretty intuitive. A lot of times you're looking at code that Microsoft has written. When you fire up a new solution in Visual Studio, it comes boilerplate with a lot of code from Microsoft. And a lot of times what you're doing is just basically cutting and pasting that code. So if you have a controller, they usually supply one controller that's got some stuff in it. And if you want to make another controller, a lot of times you just make the other controller, and then you cut what's in the first one that Microsoft gave you, and you paste it in the second one, and you make the changes that you need to. And so I think that naturally you kind of learn the Microsoft sponsored naming conventions, which are pretty standard. And then I remember in my first contract at Intel, I was kind of working on my own. Didn't have a lot of guidance. They just said, do this. And so as I coded, I would come back to code that I might have written the previous week. And I said, it's not really that clear what that variable is trying to say, or that's a really ugly name the way I've capitalized it. And so I kind of played around a lot. I rewrote my code many, many times saying, should I capitalize it this way? Should I capitalize it this way? And the funny thing is that what I decided was the most readable way to do it turns out to be the way that Microsoft suggests. An example, if you have an acronym, so ordinarily you camel case things. So you would start with a small letter. So last name would be little l, little a, little s, little t, and then capital N, and then small letters. What if you have an acronym like SSN for Social Security Number or MLA? The most readable way I found, which actually tends to be what Microsoft recommends, is to make it lowercase. if it's more than 2 letters. So IC would be uppercase, but MLA would be little MLA, or little SSN. Um, so what would be so if you had SSN present, it would be little s, little n, and capital P for present. And so I just found that was the most readable, and it just turned out to be what the coding convention was. So for me, naming conventions were pretty intuitive, but I kind of had to play around with mine too until I was really happy with the fact that they were readable. But they're fun. That's I guess it it makes me kind of a small picture guy, but I kind of enjoy doing that kind of thing.
That's awesome. Let's see. Just a few more questions. So, how does acceptance criteria different for a developer and a tester if we consider some project like building a wireless modem or a software app like Netflix?
They should be the same, is what I would say, because again, they are the testable items that confirm that you've done what was conceptually laid out in the story. So if the story says conceptually, I want you to do this, and then the acceptance criteria are, that means that if you do this, that this will appear in the table. If you do this, it will be converted to this. If you do this, it'll set this flag. Very specific testable endpoints. And those should be the same endpoints that you're looking for when you're doing your dev testing, and the same endpoints that the QA is looking for in the QA environment. So they should really be exactly the same.
Got it. And then next question. So can you please explain the difference between the definition of done, DoD, and acceptance criteria? And then following that up is, are these two terms, acceptance criteria and the definition of done, applicable to the developer dev team only, or are they also to the tester team as well?
There is no one answer, because those statuses are set by the actual enterprise that you're working for. So at Genesis, we say done, but we've kind of played around with our different statuses over time as we've found what works for us. I mean, basically, you want to have a status so that the lead developer or the manager can look at a story and say, oh, or the sprint or the scrum master can say, oh, that story is ready to go into Pit, so I can start testing it in Pit. So it, I don't know that there really are standards as far as what the status is. That's going to depend on your company. But for us, done means that it is deployed to prod. So we have a rotating deployment manager role. So I do it every 4 weeks, or every 4 sprints, I should say. And so one of the things that the deployment manager or the release manager will do after they've done the release at 8 at night, when everyone's all the stores are closed across the country and you can go ahead and mess with things without bothering anybody, is you'll move, if the deployment was successful, you'll move it from the ready for production status, which means it's in the Pit environment, it's been tested, it's ready to go, and you'll move it to the done status. So for us, that's what done means.
Great, thank you. And then one last question is from Layla. So this is following Martin's question. So Azure DevOps, GitHub were mentioned. Does that mean that we can use GitHub to practice Agile or deployment as well? So they use GitHub before for their projects / repos, but not with Agile or deployment yet.
Yeah, so I have my own Git account where I keep all my code, and as you can see, I just signed up for an ADO account just last week. Super simple, and I'm pretty sure you can do the same with GitHub. I actually don't have a GitHub account, but yeah, I think you just go to GitHub, sign up, and you got no free account. So,
Great.
like I say, it's GitHub is very standard. There are other repositories like Bitbucket, but I think for the enterprise environment, that ADO and GitHub are the two biggies, especially for .NET companies.
Got it. All right. So I believe that was the last question, but if in case anybody else has any questions, would your LinkedIn be a good place to follow that up with?
Yeah, absolutely.
I actually have it right here, so let me just quickly grab it. Also, just to let everyone know, we are recording this, so you can definitely watch it back later today or on Monday. And it should be under the Tech Talk playlist on our YouTube channel. Let me also share that link with you. You can also watch all the previous talks we've had. Here you go.
All right. And there was one last.
It looks like actually you were about to say, so it looks like one last question. Could you please explain the difference between agile and safe skilled agile? Sorry, let me
I'm going to
read that
admit
again.
I don't know. I'm not familiar with SAFe.
Got it.
When I'm
Um,
interviewing people, by the way, that's actually one of the things I look for is, if they just absolutely don't know, can they say, I don't know? Because it's easy enough to Google stuff, but it's important to know when you don't know something. So this is something I don't know.
okay. Maybe this is something you can actually look into later yourself and, learn something new.
Yes, that's why interviewing is so much fun. Is you come across these questions. It's like I was asked about this. I'd never heard of it before, and you go home and you Google it and you learn. So
Exactly.
after
Or you
after a
can
while,
just use
interviewing gets kind of fun.
ChatGPT. Yeah. All right. Also, next week we have another Tech Talk as usual, and it's actually going to be on Google Analytics 4. It's just an introduction. So if that sounds interesting to you, here's a link where you can RSVP for that event. But other than that, thank you so much, Chris, for joining us. We really appreciate it. And also, thank you for everyone joining us. And I hope everyone has a great weekend and happy Friday.
Yeah, thank you, everybody.
Of course. Thanks, Chris.
All
Have a good
right,
weekend.
we'll see you.